On a velocity time graph, we have time on the x-axis and we have velocity on the y-axis. So this is showing us the velocity of some object over time. You can just think of a car. And so let's start with part A. It says describe the object's motion in words from 0 to 3 seconds. We're talking about this segment here. Let's use another color. This color here. And from 3 to 5 seconds, if you're looking at the time down here, is this section here. So let's take a look at it. For part I, this salmon colored section here, the velocity is staying at 5 meters per second constantly for those 3 seconds. So we can just say constant velocity. Constant velocity. It stays the same. Cool. And if we look at the next section, the blue, as from 3 to 4 to 5 seconds, the velocity is decreasing. So we go from 5 to 4 to 3 to 2 to 1, and eventually to 0. So not only is the car slowing down, at the very end it goes to 0 speed. So when you're at 0 speed, you're stopped. So we can say motionless, or the word we like in physics is rest. It's at rest at the end. That's at that very specific time at 5 seconds that it's at rest. Okay. Let's go on to the next one. What is the velocity at t equals 1 second? So you look at 1 second. Velocity is on the y-axis, so all you have to do is look up here and just tell me what the velocity is. That is 5 meters per second. You can't really show work for part A or part B. Oops. And let's look at part C. What is the acceleration at 4 seconds? Notice that nowhere on this graph does it say what acceleration is. It's a little bit more abstract than what's just given on the graph. Acceleration means a change in velocity. So clearly here we are not changing velocity at the beginning there. So all we have to do to figure out the acceleration is look at the slope. This is what we call in math a zero slope. So the acceleration is 0 for that part. But they didn't ask us for that part. They asked us for for 4 seconds. So at 4 seconds, we are looking at this part of the graph. So the car is changing velocity, so that's an acceleration. And all we have to do now is figure out the slope of this. And so we go from this point here to this point here. And you start at the left one, always start at the left one. You go down 1, 2, 3, 4, 5, and you go over 1, 2. Now this is a -5 because it dropped. It goes over +2. So let's go down here and show some work. So we can say that acceleration is going to be equal to the slope. So A is equal to the rise over run. This is the equation that we want to use every time. This one is just for the notes. We're just writing it all out, that on this graph, the acceleration is equal to the slope. So we'll say A is equal to -5/2, and your calculator will tell you that is -2.5 meters per second squared are the units for acceleration.